All right, welcome back to the fourth physics lesson. This is Introduction to Energy with me, Aaron, and Eva on the other little box in the corner. The man pictured behind the text is James Prescott Joule, which is an unfortunate name nowadays. He is known as the father of energy because I don't know why, but he just is. So we'll get rolling on this presentation with Eva, there we go. So what is energy? The question that we are answering here, and energy is the capacity for doing work. And you may be wondering what work is, and we are not going to answer that in this presentation. So.
Okay, so there's lots of different types of energy. They're all listed on the screen here. There's kinetic energy, sound energy, and as you can see, the rest of them. But the main ones that we're going to be focusing on today are kinetic energy and potential energy, and the different types of potential energy.
Yes, so kinetic energy and potential energy are essentially the two kind of fundamental forms of energy. Kinetic energy, while it can take on many different forms, is essentially just the energy of motion. If an object is moving, it has kinetic energy. However, the amount of kinetic energy it has is highly dependent on the mass of the object and the velocity at which it is traveling.
Mm-hmm. Okay, and the second one is potential energy. So when we say that something or someone has potential, we're basically saying that it has the capability to do something. So as you can see on the screen, the potential energy is energy that is stored or conserved in an object or substance. And the stored energy or potential energy is based on the position, arrangement, or state of the object, or kind of where it is. So essentially, potential energy is energy that has potential to do work. And there's two types of potential energy that we're going to be covering today, which are elastic and gravitational.
But first, let's take a look at some examples. I guess this is an example of the gravitational potential energy. On the left, we have the GIF or GIF. I don't care about the pronunciation. I'm trying to remain non-controversial. But on the right, we have an example of gravitational potential energy. So as you can see on the left, we have the roller coaster at the top. At that point, it has the maximum amount of gravitational potential energy because it is not in motion and it's so high off the ground. So when it is, because it is in this position, it has the potential to fall or roll down the roller coaster, and thus it has a bunch of potential energy, or gravitational potential energy. Then on the way down, we see that it is exerting its potential energy, and that turns kinetic energy, or the energy of movement, because it's moving. So that energy is the potential energy, or the gravitational potential energy is converted to kinetic energy, the energy of movement, as it goes down the roller coaster. Then when it goes on the way back up the roller coaster, the kinetic energy is slowly converted back to gravitational potential energy because it is slowing down and it is getting farther away from the Earth, thus having more potential to fall.
Mm-hmm. And so there's different factors that affect gravitational potential energy, but the main one is height, or the distance that the object is further from the ground. So on the image on the left, there's two skiers, the yellow skier and the blue skier, and the blue skier has more gravitational potential energy because they are at a greater height than the yellow skier. So yes.
Okay, so for our last example, we're going to look at elastic potential energy, which is essentially the energy stored in elastic materials as a result of compression or stretch. The best example of this is a spring, and probably the most easily understood example. So when you press down on the spring, it gets all compressed, and because you're pressing down on it, it's pressing back against you, and that energy that when you compress it, it has stored potential energy because it is not moving, so it doesn't have kinetic energy, but it has the potential to expand rapidly once it is released. Essentially the same concept as gravitational potential energy, but in a different form. And also this works when a spring or elastic object is stretched out. It wants to pull back together and compress again to its like average resting state. And because it can't do this, it has a bunch of potential energy um, waiting to be released in kinetic movement. So,
Okay.
thank you for coming to our video, and I hope you now have a newfound understanding of what energy is.
And then next time we're going to be going into some of the different types of energy as well.